We are going to here solve the questions of the R.C. Mukherjee book. Here we have R.C. Mukherjee book. This is the first question of the R.C. Mukherjee book. Here we have to find out number of atoms in 48 gram of ozone at NT. Here the one thing should be clear to you that this is useless. There is no any use of this particular thing here in this particular question. This is useless. Why this is useless? Because the NTP is used to calculate the volume, because we know mole is equal to, this is volume in liter at NTP divided by 22.4. So dear friends, here we have not to calculate the number of moles. That's why this particular thing is useless in this question. Now, here we have to calculate the number of atoms in 48 gram of ozone. 48 gram of ozone. So, the first method that I spell as a lengthy method, long method. Here it is given 48 gram of ozone. 48 gram of ozone means O3, and this is the uh, molecular form of the substance. This is molecular substance. Molecular substance. Since this is molecular substance, so firstly we will calculate to number of molecules, and then we will calculate, then we will convert to that number of molecules into the atoms. Now here we know gram molecules. This is equal to mass in gram upon molecular mass, and this is equal to number of molecules upon number of molecules. Here it is number of molecules upon Avogadro's number, Na. So here we can say mass, it is given 48 upon molecular mass. It is also 48. Here is O3, and if we calculate molecular mass of O3, then this will be 3 into 16 is equal to 48. This is equal to number of molecules divided by Na. So we can say here number of molecules, this is equal to Na. We have to calculate the number of atoms. So we can say since one O3 molecule that contains 3 atoms of O. So we can say NaO3 molecules. This is Avogadro's number. This its value is 6.02 into 10 to the power 23. So NaO3 molecules, this contains 3 Na atoms of O. Here we can say now number of atoms, this is equal to 3 into 6.02 into 10 to the power 23. It will be approximately equal to 1.8 into 10 to the power 24. So we get the right answer from here. Now I told you this is the lengthy method. This is not the shortcut method. So what shortcut method we can adopt here? Here I have to erase till this point, these unnecessary points. What shortcut method? So second method to that we can select here. We will apply the mass conservation law of mass conservation. Law of mass conservation. We can say mass of O3 is equal to mass of O. So here mass of O, it is atoms, it is equal to same thing is 48 gram, which is given here in this. So mass of O here, it is atom, it is 48 gram. So we can say gram atoms, it is equal to mass in gram upon atomic mass. This is equal to number of atoms upon Na. Mass it is 48 and atomic mass is 16 into Na. This is equal to number of atoms. So from here you can say easily 3Na is equal to number of atoms. So dear friends, these are two methods. This is shortcut method and this is lengthy method. I don't like this method. I don't like this method. I little like this one method, little, not more, because we can use some more methods. There are many methods of this. I'm rubbing this part again because I have to apply the third method to solve to this question. We have to build up the concepts. Question may be little small or question may be little big, but finally what we have to do, we have to build up our concepts. Here we can say it is now clear that uh, 48 gram of O, this is atom, and from where we obtain this? We obtain this by applying law of mass conservation. We obtain this by applying law of mass conservation. Now we can say atomic mass of oxygen, it is 16 gram per mole. It means since 16 gram is equal to 1 mole of atoms of O, so we can say this given 48 gram, this will be equal to 3 moles of atoms of O, and we can say it is 3 Na atoms of O. This is the third method that I told you. This was third method. We can use one more method. Here, fourth method to solve to this question. Here again I am writing atomic mass of O, this is equal to 16 U per atom. 16 U per atom. I writing here 16 U per atom. It means 16 U. This is equal to 16 into 1.6 into 10 to the power minus 24 gram is equal to 1 atom. Here, 1 U is equal to 1.6 into 10 to the power minus 24 gram. This must be in your mind, and I described it in my past lectures. So this keep in your mind. Now, this gram is equal to 1 atom. So we can say 48 gram. This is equal to 1 upon 16 into 1.6 into 10 to the power minus 24 into 48 what atoms. From here we can say it is 3, and now this is equal to 3 upon 1.6 into 10 to the power minus 4. It is atoms, and this will be equal to 3 into 6.02 into 10 to the power 23 atoms. Now, one thing you should also keep in your mind that as you did it, 1 upon 6.02 into 10 to the power 23 gram is equal to 1.6 into 10 to the power minus 24 gram. This is the calculation to that you have to keep in your mind. I give you the 4 methods for solving this particular question, and this is my philosophy that we should develop the concepts of the students. Now, I'm giving you little notes. I told you here we have to write some notes. What? If atomic mass, suppose it is X. So this gives us two informations, X, U per atom, and at the same time it is X gram per mole. I describe it in my past lectures, but here this should be in your mind. And if and what 1 upon 6.02 into 10 to the power 23, its calculation will be 1.6 into 10 to the power minus 24. And these are the two. And one thing more, 1 U. U means 1 atomic mass unit, or AMU, 1 AMU. This is equal to 1.6 into 10 to the power minus 24 gram. So I'm repeating, I had repeated this because I teach these 3 points in my past lectures. Now we have to solve to this second question. What will be the ratio of volume occupied by 1 mole of O2 and 1 mole of O3? Here, 1 mole of O2 is given and 1 mole of O3 is given, and there is it is given identical conditions. So suppose that it is at NTP and it is also at NTP. You know, its volume is 22.4 liter and its volume is also 22.4 liter. So you can say if the conditions are identical, then the molar volume of the gases are same. That's why the ratio of these two, you can say 1:1. So here, what note we can draw from here? Under identical conditions of temperature and pressure, equal moles of gases occupy equal volume. For example, here we can say volume of 1 mole of any gas, any ideal gas. Here I am telling gas at NDP, it is equal to 22.4 liter. Volume of 1 mole of gas at STP, it is 22.7 liter. So under identical conditions, equal volume of gases occupying equal moles of gases occupy equal volume. Now we have to solve this question number 3. We have to solve to this question number 3. The vapor density of gas is 11.2. Here, vapor density is given 11.2. We know that molar mass is equal to 2 into vapor density. So it is 2 into 11.2. So it is 22.4. This is the molar mass. Calculate the volume occupied by 11.2 gram of gas at NTP. This is the molar mass. This is molar mass. And it is telling 11.2 gram of gas is given, and we have to calculate molar mass. What is molar mass? Molar mass means mass of 1 mole of gas. Since this is molar mass, that is 11.2 liter, so we can say this is the mass of the 1 mole of the gas. What is molar volume? What is molar volume? It is volume of 1 mole of gas under given conditions of temperature and pressure. Under given conditions of temperature and pressure. Now, dear friends, we can say that this is the mass of 1 mole. So we can say that 22.4 gram is equal to 1 mole is equal to 22.4 liter. We know that at NTP, molar volume is this. So you can say 11.2 gram is equal to half mole is equal to 22.4 divided by 2 liter at NTP. So this is 11.2 liter at NTP.